Good evening. My name is Ed Levi. Before John started teaching the classes, I taught the classes for about 15 years, and then John took it over and did a better job than me. I was the apiary specialist for the state for 25 years, and I've been a beekeeper for 50 years, starting in France. I went to a school there to learn beekeeping and then kept bees there for 5 years. Since then, I've worked with a lot of beekeepers around the country, especially in Arkansas, working for the state government here. But the last 20 years, I've been working in developing countries, working with beekeepers. So tonight, I want to talk a little bit about bee biology. And the reason I want to talk about bee biology is, as beekeepers, you're going to be guardians for the bees. And it's hard to be a good guardian if you don't know how bees work. And we're not going to talk a lot about anatomy or anything like that. We're going to talk about how bees work, basically. And therefore, from that and the continuing classes afterwards. Okay, is that working?
It's the handheld one.
Okay, sorry. Did you hear anything? So, like, if you have horses, you have to know how to take care of horses, and if you have cows, you have to know how to take care of cows. If you have bees, bees don't work like people. They're different, and people tend to. There's a word, anamorphize. People tend to think that bees are like people, and there's a lot of mistakes that are made in doing that, but there are things that bees do that make sense. Like John mentioned in the video, that bees can become defensive, and so did Earl. Bees can become defensive. Well, we all can become defensive. If somebody takes our roof off and moves our furniture around and throws us out on the ground, we're going to be defensive. And so we can understand some of the things. We can understand swarming, and I'm going to talk a little bit about that, because our kids all swarm. My kid swarmed, and he's living in Brazil. So I want you to learn a little bit about biology, and I need to learn how to do this. Okay. So beekeeping is called apiculture, and the picture on the left there is actually a Nepali beekeeper. It's with a different type of bee. It came out of the wall of their house, but they kept it in the wall of the house on purpose because they could access it from inside the kitchen and get a little bit of honey periodically. But he wanted to move it into a hive, so we worked together to do that. The picture on the right is basically the outcome of a class that we taught up here in Fayetteville, and that's in Lowell, and the beekeepers going out to the bee yard to learn about the things that we talked about in class. So beekeeping is applied bee biology, so that's why we need to talk about biology. We accept and work with bee biology as beekeepers, but it's basically a craft, but it's a craft based on science. I can't tell what's advancing and what's not. Some things we can relate to as humans, like I said. Sometimes we make mistakes, assumptions. For example, the bees don't, in the wintertime, the bees don't heat their space. We tend to heat our rooms and close the windows and everything. The bees don't do that. They close the windows a little bit with propolis, which we'll talk about in a minute, but they don't heat the space, they heat the cluster. And so we'll talk about clusters and how that works. I was working in Armenia one time, and this guy was so proud. He showed me how he heated his hives by putting cans of sand in each hive and putting a light bulb in the sand. But it doesn't do any good. And, you know, I couldn't tell him that he was wrong, but I didn't know how to speak Armenian. But there are things that that we do understand. And among those things is about how they live. John showed a picture of a bee tree in his video, and that's how bees lived before people came along. And they still live like that. They find cavities that are appropriate for them. They need a shelter. They need the right bee space. They need a way to defend it. And is there any way to make this bigger? I can't see. I don't know what I'm supposed to be saying. Maybe if I put on my glasses. That takes some of my pride away. So this is just showing the next one. This is what's up.
Oh, your glasses look great.
That's right.
My glasses look great, thank you. You make me feel so much better. I already told you that 50 years ago I started beekeeping, so you know that I'm not young. No, that's all right. I'll manage. Okay, so they adapt to a nest, and Mr. Langstroth designed the hive that Earl and David showed you to sort of resemble that nest. John explained that they start at the top because that's where they can hang the comb. But in our hives, they start at the bottom and they put the honey above the brood nest. Even in a tree, they'll put the honey up there eventually, and they'll put the brood at the bottom of the comb, and then as the comb goes down farther, they'll put the brood farther down. And they usually put the honey above the brood nest. They need a defensible entrance, and they have preferences on size and dimensions. In fact, when a swarm goes out, the scouts actually measure the cavities that they find to move into when they tell the other bees where they're going. They construct the parallel combs that John talked about, and that has the bee spaces. They make cells that are all hexagons, which is the strongest shape there is. That's why the grills of Dodge trucks have hexagons on them and stuff. They haven't found a design of a shape that is stronger than the hexagon, and especially the way the bees build it, that uses the least amount of material to hold the most amount of weight. So what they do is they make their combs so that the backs are not directly behind each other, and as David's mentioned a little while ago, the cells are slightly slanted upward so that the wet nectar doesn't come out. And that hexagon shape, I mean, they're architects basically, and that hexagon shape is very important. Bees went on the early space shuttle, and they wanted to see what they would do in zero gravity. So they took some bees with them, and at first they made their comb just all haywire and stuff, and then they figured it out and they straightened it out. So they're pretty intelligent, being that their brain is a little bit smaller than a half a grain of rice. The bee space, you've heard a lot about, between 1/4 and 3/8 of an inch. There's the parallel comb. They're very organized. Their brood area and their food area are very organized. And then they make special cups for the queens, if they're gonna raise a queen. So where did bees come from originally? There's several different races of bees, and those races can be separated into 3 different continents. And then in those continents, there's species, and then there's subspecies and hybrids. So in the US, we have a lot of different types of bees. Although bees did not originate in the US, like John said, it was the Pilgrims that brought the first bees over here to both North and South America. They came from Asia, Europe, and Africa, and then eventually they got to the Americas. So basically we've learned that the bees started in Africa, and I've been doing a lot of work over there recently. And they went from Africa to Europe. They changed during that time. Bees have been around for 35 million years. They sort of came about at the same time that flowers came about. And they have a symbiotic relationship with flowers and bees. After Europe, the Pilgrims brought them to the Americas. The bees in Asia are different. The bees in Africa are a little bit different. But what we have in the US are basically European bees. The major races of honeybees in Africa and Europe, they're all Apis mellifera, except for one bee down in the Cape of South Africa. Apis mellifera just means honeybee, basically. There's many subspecies, and there's a lot of different characteristics in between those subspecies. There's also different behaviors. And I've got a research project going on, I'm just about to finish it up in Madagascar, about the behavior of the bees in Madagascar, because they're very different from the bees in the rest of Africa. They're unique to Madagascar and the Seychelles Islands. In Asia, there's several different breeds of bees. They've imported the western honeybee now, but Apis florea is a little teeny bee, won't live in a hive, it lives on sticks. Apis cerana is a little bit larger, and it will live in a hive. And actually, they have Apis cerana and now Apis mellifera European bees in the same apiary sometimes. They don't cross, but they coexist. Apis dorsata lives outside on trees and under eaves and stuff. And then in John's video, he talked about the cliff bees in Nepal. I hiked for 5 days to see those cliff bees. That's Apis labasaurea, and they live on the side of the cliffs very high. So this is a honeybee. Scientific name is Apis mellifera. We don't know what species it is. It's not a queen, it's a worker bee. Queens do not forage, they don't go to flowers basically. Only the worker bees do. Here's a picture of a queen in the middle. You can see her right there in the middle, and then a bunch of workers around her. What do the workers do? We're going to talk about that. So basically there's 3 castes. There's the queens, which there's only one reproductive queen in a hive. Normally, every once in a while you'll find more than one. I had one situation where I found 9, but it's very unusual. Their function is to lay eggs. They're basically just an egg machine, and they produce chemicals. John mentioned pheromones, and I think Earl did too. Pheromones are different than hormones. Hormones are things that our body produces to tell our body to change or to do something or something like that. Pheromones are chemicals that come from other bodies that give directions to others. So that pheromones are extremely important in beekeeping. We all know that about the bee dance, and the bees communicate with the bee dance. Pheromones are the main way that bees communicate. The worker bees, what's it going to say? Doesn't want to advance, okay. There's a number of different jobs that the worker bees do. That's why they're called workers. They work themselves to death, literally. They do cleaning, they do nursing, they do guarding, they collect nectar, they ripen the honey, they store the honey, they're foraging all the time. And then there's the drones. The drones are the male bees. The male bees' main job is to mate with the virgin queens. And that sounds really cool in a way, but when they mate, they die. And if they don't mate, they die. So it's not that cool of a job. In my mind, the drone, I mean, if you looked it up in the dictionary, it probably wouldn't say this, but basically they're couch potatoes. And they go out and they find an area where they think virgin queens are gonna fly because they mate on the flight. And a bunch of drones go there, they're called drone congregation areas. And they'll usually be alongside a hedgerow of trees or in a slight lower place. And they have big eyes, and they also have good smell. And so they can spot a queen really fast, and they chase after them, and the queen mates up to 17 times with different drones. And she stores all the semen and sperm in something that's called a spermatheca, and it gets mixed in there, and so the offspring are a little bit different from each other. They're all sisters because they all have the same mother, but they might not have the same father. The colony works as a unit to promote the continuance of a species. Everything does that. Everything that's alive does that. Apples, they don't make apples for us. They make apples to feed the seeds while it's working its way into the soil to make offspring, to continue their genetics. And bees are the same way. We're the same way. We all like to continue our genetics. This requires propagation. And I sort of break propagation into micropropagation and macropropagation. The micropropagation would be raising young bees. So with our western honeybee, 21 days after a female egg is laid, if it's not going to become a queen, it will become an adult bee. And so that's propagation. And the queen is laying in between 1,000 and 2,000 eggs every day. And so 1,000 and 2,000 eggs in the springtime, and in the early summer, there's that many bees that are hatching out. Now, they don't live all that long. They live at a maximum of 42 days. And so they're dying at the same rate. But during the spring, the queen's laying more and more eggs, and so the population grows, and in the fall, she slows down and the population descends. Then there's swarming. Swarming is the macro propagation. It's like if your kids move out and start a family someplace else. But swarming is a little bit different than that. We'll talk about that in a minute. So we have the three family members, the queen, the workers, and the drones. The queen is the colony's mother, usually only one per colony. She lays between 1,000 and 2,000 eggs a day. I'm being redundant on purpose, by the way. Bees learn redundantly, and so do we. They're responsible for the colony's identification. They produce a lot of pheromones, a lot of different pheromones. One of the pheromones is different from every other queen. It's made up of 21 chemicals, but the recipe is different than the queen next door. And so, because the bees are living in a small area and all touching each other, they all end up smelling like the queen's pheromone. And for that reason, they only let in sisters. They won't let in bees from other colonies, except under certain circumstances. They're cared for, the queens are cared for by the workers. They survive from 5 to 8 years under perfect conditions, but during that time, their quality drops with their age. So they'll be laying fewer and fewer eggs, their patterns will get a little bit messed up, they'll run out of semen, and therefore will start making more drones, which I'll explain in a minute. And the queen gives half of the genetic traits to her offspring, just like our parents. We got half from our mother and half from our father. But with bees, it's a little bit different, but they get half of it from their mother. Different traits of different bees are different, even within the same species. Sometimes you'll have different ones. Gentleness is one that we like. Sometimes we get bees that are not very gentle. And if you get bees that aren't very gentle, you change the queen. So when you get in 21 days, you start having a replacement of bees. Can't see that. What's that say?
Honey producing.
Honey producing. Some bees are better at hoarding honey than others. For example, the African bee in Africa or the Africanized bee in the southern states, they don't hoard as much. They make a lot of honey, but they turn the honey into bees. Our bees hoard more, and some species hoard more than others. We have a lot of different subspecies here, and some hoard more than others. Brood rearing, that has to do with the same thing. Some of them are better at making brood very fast in the late winter and early spring. Some start out slower but catch up. Some start out slower and don't catch up. So it depends on the species that you have, and it depends on the individual colony. Some winter better than others, or in some places it's not winter and it's rainy season. Some have hygienic behavior, which means that they don't like any dirt in the hive, and if there's anything wrong inside of a brood cell with the larva, they'll take it and throw it out. So they're good. The hygienic behavior is important for controlling some of the diseases and parasites that we have. Disease resistance is similar to hygienic behavior, but it's a little bit more general. Appearance, some people really like bright yellow bees. I don't care what color they are. They can be purple or orange or whatever. The bees in Madagascar are called Apis mellifera unicolor. They're black. So gentleness is important, especially for new beekeepers. What's that one?
Honey producing.
Honey producing is important for people that want honey. Some people just want pollination. How many people want bees for pollination? Yeah, several of you. That's something, in John's video, he didn't talk about that very much. Bees were brought over because of the honey value and also because of the wax, because wax was important back then. But we learned later how important they are for pollination. In fact, all the honey that's made in the United States is worth about 1/50th of the food that's produced because of the honeybee's pollination. Hygienic behavior is very important, and I raise queens for their hygienic behavior. Drones are the male bees. They're big and sort of chunky looking. Their main chore is to mate with the queens. They live for an entire season. Now, when I talk about seasons, I'm talking about from springtime until late fall. And drones are sort of like queens. They can't feed themselves, the bees feed them. And when they aren't needed anymore, they stop feeding them and they boot them out of the hive. The ones that weren't successful in mating. The ones that were successful in mating died at that time. They're cared for by the workers, and they're the other half of the genetics. But there's something interesting about them that I need to explain. My son and I had a long discussion last night because he couldn't quite, he's visiting from Brazil. He couldn't quite understand the idea of haploid. Drones don't have fathers. They have grandfathers on the female side. So they have a maternal grandfather, but they don't have father. They're haploids, they only have the genetics of their mother. So that becomes important in queen breeding and stuff. Therefore, their genetics only come through their mother. The workers are incomplete females. In other words, they are undeveloped reproductive system. They care for the brood nest. They collect all the resources. They build the comb. They stock the shelves, basically. They bring in honey and they transfer it to bees that are in the hive, and they put them in the cells and they mature it and take moisture out of it. They care for the queen and the drones until they don't. And they overwork and die at about 6 weeks old, if everything goes well. If they have diseases, they die sooner. Their jobs are broken down into categories depending on somewhat external needs, like if all of a sudden they needed more pollen or something like that, some of them will become pollen collectors faster. But mostly it's by physical development or internally. Just like us, when we were little, we didn't do much except eat and poop and sleep. But bees, when they hatch out, they go to work right away, but they can only do certain jobs because their body is only capable of doing certain jobs. When our kids become toddlers, we can ask them to bring us a fork, but we're not gonna ask them to bring us a plate that might break or a bucket of water, because they can't. So bees develop different abilities, and they have abilities that atrophy, glands and muscles that atrophy, and they can't do those jobs anymore. So what do bees want? They want to survive. They want their genetics to continue. They want their colony to continue. And they do that by raising young and by swarming. The colony organization, workers tasked by ages. They start out as what I call developmental bees or nurse bees. 1 to 3 days old, they just clean the cells where other bees have hatched out. That's their job for 3 days. The second 3 days, they're able to produce royal jelly, which is a glandular secretion in their head that is important for raising all the bees to a certain extent, and it's extremely important for the queen. They have a gland in their head that develops at about 3 days old, and it works until it's almost 9 days old, and then it atrophies. At the third 3 days, they start feeding older larvae. They feed them the royal jelly, or not the royal jelly, but the pollen and the honey mixed in what we call bee bread. It's sort of a fermented food that they make. Then they become house bees. And about 9 days old, they start building wax. They have muscles or glands, in their abdomen that is able to take the resources that they're bringing in, the nectar and the pollen, and make it into beeswax. It's the only place you can get beeswax is from these little glands. It doesn't grow on flowers. It doesn't grow in petroleum fields. It's just from bees. At about 12 days old, they start cleaning again, more cleaning, but not the little cells, but the hive, and they become guard bees, and they also heat and cool the hive. And that's a very important thing to understand, that if it is, I don't know what the temperature is outside, but it's too cold for bees. The bees are starting to make brood. I watched bees yesterday bringing in pollen, which means that they're making brood, because the brood needs pollen. And so, but it might be 25 degrees outside tonight, so they're huddling around that brood and keeping it in between 92 and 95 degrees at all times. And so they're vibrating on top of the brood to create heat. In the summertime, that brood needs to be between 92 and 95 degrees, and so your hive is sitting out in the sun and it's 90 degrees outside, and inside the hive it could be 180. So they're cooling it. They're bringing in water and they're sprinkling it around the hive, and then they're making patterns with their wings and blowing that water around and blowing it out of the hive. So they're basically created an air conditioning system, or at least a swamp. What do they call it? Swamp?
Swamp cooler.
That. The next 2 weeks, they're going to convert nectar to honey. So the nectar comes in from the flowers. The foraging bees are bringing in nectar. They give it off, they hand it off to some of the house bees, and the house bees put enzymes in it, put it into cells, move it around, ventilate the hive to get the moisture out, because the nectar is very wet and it needs to be dried for them to store it. So they store the honey and the pollen. They put the pollen in cells. They actually push it in with their heads to get all the air out of it, and then they seal it with a little bit of honey on when it's full. So there's a picture of a bee's abdomen with the the wax glands coming out, and those wax builders are gonna chew that wax and work as teams to make the cells. And they make perfect little cells. It's really amazing. These bees could be ventilating or they could be guarding, depending which way they're facing. When they guard, they do sort of like a cat that stands up and looks tough, or a dog that puffs up on its neck. When they're ventilating like that out in the hive, they could be pulling air out of the hive to cool the hive off, or they could be throwing pheromones out in the hive to tell the other bees where they are. They do that with swarms. These are a foraging bee and a house bee transferring nectar one to the other to make it into honey. The field bees are foraging for nectar, pollen, water for cooling, and propolis. And you heard a couple different people speak about propolis so far in this class. Propolis is basically a word that comes from two words: pro, in favor of or in defense of, and polis, like Indianapolis, what's another Appalachia? Minneapolis, just means city. So it's basically city defense. They're using that propolis, which is a mixture of honey and saps from trees and other plants, and mixing it and making that bee glue so they can glue things together so that the hive is strong and little spaces are closed and everything. John mentioned that they coat the inside of the hive with propolis a little bit. If you have a hive that's rough inside, or if you look in a bee tree, at the inside of a bee tree, it will all be covered with propolis. Propolis is a natural antibiotic, and so it helps them stay healthy. And a lady named Marla, a researcher named Marla Spivak, has done a bunch of research on propolis, and she's proven that bees that have propolis on the inside of the hives are healthier than when we scrape all the propolis out. So as messy as it is and how frustrating it is when you get it on your telephone or whatever, it's good stuff. And there's a market for propolis, not so much in this country, but in other countries there's a market for propolis. So at that late age, they become foragers, and those are the bees that we see out there. The next thing I want to talk about is brood development. And this picture is a picture, and the pointer doesn't work on the screen. I don't know if I can use this. Yeah. You see that arrow moving?
Yeah.
No? Okay.
Use the one on the remote. Point it to the screen or the.
No, it won't show up.
The one on your clicker remote?
No, it won't show on the screen. They told me that lasers won't show on the screen.
No, the laser won't, but the one on the remote should, if you look on the. Red button in the middle.
Anyway, the cells that have the little white dots in them, the little sticks, those are eggs. And then above those, you see some that are a little curlicue. Those are young larvae. So they're eggs for 3 days, and then they become a larva, and then they're larvae for till the 12th day after they've been laid as an egg. On the 9th day, they get covered up. So they've been fed everything they're going to be fed. They basically double every day in age once they've hatched as an egg. The mated queen lays an egg in each cell. Fertilized eggs are females, unfertilized eggs are drones or haploids. And that's hard for us to understand. My son asked questions for about 2 hours last night about that. The egg is fed royal jelly, that glandular secretion, and it hatches to a larva on the 3rd day. A bee's life consists of 3 brood stages. Almost all insects are the same this way. They're an egg. That's a cut of some cells, so you can see the egg big there. Then they become a larva. So you see the little larva or what's the other word for that? You know, they're a larva. And that larva doubles in size every day because they've been fed really well. But it's only fed royal jelly for the first 2 days unless they're gonna make a queen. And there's the larva. And then they become a pupa, and the pupa is already closed in the cell. So they've been fed everything that they're gonna be fed for their development. And then they're closed off and they develop as a pupa in there and then become an adult worker at 21 days. If it's a queen, it's 16 days average. And if it's a drone, it's 24 days. So here's what they'd look like if they were sitting on the comb instead of in the comb. Where am I? The diet has changed from pollen to nectar on the fifth day. It stops the development of the reproductive system. So the workers are females, but with incomplete reproductive systems, because as soon as they're fed bee bread or nectar and pollen, it stops the development of the reproductive system. The larva is fed and sealed on the 9th day. On the 12th day, it becomes a pupa. On the 21st day, an adult worker emerges. So as a beekeeper, you would look at a frame like that. This is honey up here across the top. This band that goes above this is pollen. They always put the pollen near the brood. And then the lower part is sealed brood all over 9 days old. So the beekeeper's looking at that, seeing that they're laying a good pattern, and knowing that the queen is doing a good job. But really, to know if the queen's doing a good job, you need to look for young brood, because maybe this is maybe 18 days old. And maybe you were in there 17 days ago and killed the queen by accident. This actually is a brood chamber that was above the bottom brood chamber, because you can tell by the pattern that would have made an oval down here. So if you looked here, you would see the brood pattern like that. And if you looked in an upper box, it would be the opposite.
I think you advanced a couple times.
Oh, I'm sorry. What did I do?
Yeah, you advanced several slides.
Oh,
Go back about 5.
about 5. Yeah, you did. Wow. One more.
There we go. That's it.
Okay, sorry about that. So foraging, bees are gonna fly out when they're between 4 and 6 weeks old, sometimes a little bit sooner depending on the needs of the colony. And they're gonna fly out and look for food. But what happens is scouts go out first and find food. And they come back and they dance, and their dances tell the other bees whether the food is good, how excited they are. There might be different dances going on at the same time. What direction it is and how far it is. So like if somebody went out of this building right now and came in with a fancy drink or a fancy candy bar or something like that, and everybody wanted to know where they got it, and they couldn't talk and they couldn't write, they would have to do a dance. I explained that at a meeting recently in Madagascar, and I got the vice president to do the dance. After 3 or 4 weeks of the life of the bees, they take flight and become field bees. The queen's development is a little bit different. She's fed only royal jelly that develops her reproductive system. She's raised in a peanut shaped cell that protrudes from the brain, and she's fully developed in 16 days. The difference in brood, queen develops in a vertical cell, a worker and drones develop in horizontal cells. There's a queen coming out of a cell there. There's a graphic showing the queen is laying an egg, and then the workers feed the hatched larva, and the larva reaches full growth, and then it's sealed, and then it becomes a pupa, and then the adult bee leaves the cell. So you're gonna, all of you that end up getting bees, you're gonna see all this, and it's gonna be important to understand it, to understand what's going on in the hive in order to be a good guardian of your bees. Because sometimes they need some help. Drone eggs are unfertilized haploids. Queens receive only royal jelly. If ever they're fed nectar and pollen, then they won't develop as a queen. So if something happens to a queen in a hive, you might get an emergency queen cell. They'll just take any egg and feed it only royal jelly and change the shape of the cell and turn it into a queen. But that takes a long time. It takes 16 days to develop a queen, then it takes almost 2 weeks more before that queen starts laying eggs, and then it takes 21 days more before those eggs start being adult bees. So your population is going to be going down during that time. So workers and drones only receive the glandular food for 5 days, and then they get nectar and pollen. I can't read that. This changes the diet and stops the development of the reproductive system. The amount of food is less for workers and drones and larvae. Cell orientation is different. The development of the drone is an unfertilized egg, and it's in a drone-sized cell, normally. So before a queen lays an egg, she sticks her head into the cell, makes sure it's clean, and she measures it. If it's a big cell, she actually makes a decision, and I don't know how she does it, because I can't get myself in her head. But she makes a decision to not put a sperm with that egg in order to have a male hatch out of it. If it's a normal sized cell and she's in good health and everything, she will put a sperm with each egg and it will become a female. Drones mature in 24 days. Those are all drones coming out of that picture. Communication is extremely important in bees. That in order for them to do everything that they have to do, they have to work like a team. And they work very well as a team. They'd be a good example for us. In fact, they'd be a good example for our legislature. And I say that half laughing, but we found out in the last maybe 10 years that bees actually have debates, and they argue, and they make decisions, and they go with the decision. But bees have to communicate, and they do that to identify the colony, the needs of the colony, the dangers to the colony, and the location of resources, and on and on and on. Queens, for example, have glands in their feet, so that when they walk around laying eggs, the workers know in what order the eggs were laid, so they feed them in time. Now, that seems strange to us, but we've all seen ants walk in straight lines. And yet, if there's a little bit of rain, even a drizzle, they scatter. It's because they're leaving pheromone trails, and then when water gets on it, they get lost. So how do bees communicate? We know that they use pheromones, and I'm only mentioning a few of the things. There's about 50 different types of pheromones. And the larvae have pheromones, the worker bees have pheromones, the queens have pheromones, they all work with pheromones. And that's the main way that they communicate. And that's when Earl talked about, you don't want to kill your bees with smoke. You just want to give them the minimum you can get away with, because you don't want to confuse them. It's going to mess them up for a while. Also putting strange things in the hives. A lot of people are using a lot of different chemicals to control different parasites and diseases and stuff. Those are odors that are going in the hives that mess up the communication of the bees. They also use dance. And dance is important, but not near as important as the other, but it's important for swarming, it's important for foraging. So there's a picture of a queen with an entourage around her. They're all touching her and grooming her with their antenna. They smell with their antenna, by the way. And while they do that, they pick up her pheromone, and then they walk around the hive, and everybody else touches them, and they all pick up that pheromone. There's a bee dancing. You can see on her hind leg, she's got some pollen there. She's doing a dance, and bees are smelling the pollen and seeing the dance and feeling the dance. It's in a dark space on a vertical plane. We can't dance on the walls, or most of us can't. But the bees are learning there by redundancy. They're watching that dance over and over. Some of them are copying the dance, and then they go out and they know which direction to go and how far to go. Now, there's some arguments about the distance, and science hasn't really decided which is true, whether the wag of the tail tells the distance or tells how much fuel they need to get to where they need to go. So like an airplane, if an airplane takes off from XNA and flies to Dallas, it's not going to fill its tanks because it'll be too heavy to land in Dallas. It'll wreck the runway. But if they're flying to Madrid, they're going to fill their tanks. So the bees, one theory is that that's what's happening. I want to talk a little bit about their communication. They're doing our bidding. They're pollinating for us. They're making food for us, and they're making honey for themselves. And they have this symbiotic relationship with flowers because the flowers need them and they need the flowers. And that's why they developed at the same time. There's two different basic bee dances. There's more than two, but there's two basic ones. But the information is passed redundantly. The taste, the bees give out samples of the food sometimes. The smell, the odor of the food is on their body. And then the richness, the more vigorous they are, the better the source might be. And then the direction, distance is the angle of the dance shows the location of the source. And then also when they do part of the dance, they make a buzzing sound for the bees to hear. Now, bees don't have ears, by the way. They hear with the hairs on their body, vibrations. Remember that this is on a vertical plane, and the shorter cycles mean that it's closer. If it's real close, they just do a figure eight and they say, hey, it's just outside, just go find it. But if it's farther away, they do a different dance, and there's a bee dancing there. They do a wagtail dance, which shows the distance of the food source from the length of the wagging portion of the circle. And the direction is orientation with gravity in a dark hive, and it's oriented in relation to where the sun is. So because they have 5 eyes, some of those eyes see ultraviolet. So they can tell where the sun is even if it's totally overcast. They see the sky in spectrums because they have many facets on their big eyes. The color and taste are also clues. There's a bee The figure eight is the wagtail dance is basically 2 circles with a wagtail through it. The direction of that wagtail, for example, in here, the bee is doing the wagtail going upward. That's directly towards the sun from the hive. If it was going downward, it would be the opposite direction. If it was off to the right, at 45 degrees, it would be off that way. I'm going to speed up. I was told I'm running out of time. So there's some graphics that show the angles of there's the hive and the flowers and then the sun. And it's all relative to that. It's just more of the same, explaining it. The main way bees communicate is the chemical released externally from one bee, which stimulates the response from others. Queen substance is a pheromone that identifies the colony. It also controls the retinue of the colony. It's the rearing replacement. It stops other queens from developing if there's brood. The brood's giving out pheromones that say that they're developing. All of these things are extremely important. I'm very careful about what I'll put in my hive or what I'll use as my smoker because I don't want to mess up their communication too much. So pheromones are the main way that they communicate. The worker pheromones, orientation and setting, and I showed you that picture of the bees fanning outside. If you catch a swarm and some of them go in the hive and the queen is in the hive, the bees will push a plume of pheromones out into the air to tell the other bees, here's where we're landing. This is a picture of a pheromone that we all will become familiar with. It's right on the rear end of the bee, right next to its stinger. It's the alarm pheromone. And when a bee stings somebody, they touch them with that pheromone and mark where they stung them. So other bees know that that's where there's a danger. So when you get stung, the first thing you want to do is scrape that stinger out. And the second thing you want to do is cover up the pheromone. So I actually use the smoker to scrape out the, there it is, to scrape out the stinger. And I accomplish two things at once. There's a mandibular gland, there's working sting glands, there's a stinger. You do not want to pinch a stinger to pull it out because the stinger has a little sac on the end of it, a venom sac, and it detaches from the bee when it stings, and if you grab it and pull it out, you're just syringing that venom into yourself. So you want to scrape it out with your hive tool or your fingernail or a credit card, or depends on how much money you have. Swarming is another thing. The queen reduces egg laying and loses weight. She's put on a diet. The workers actually reduce activity, increase their honey stomach contents. The bees emerge usually between 10 and 2 in the day. It's a random division, but mostly older bees. About 50 to 75% of the bees leave the parent hive, and they cluster nearby to find and send out scouts to find a good place to live. Now the scouts will actually go out a little bit before the swarm happens to start looking for a place. But if you find bees that are swarmed on a branch and you walk up to them, you'll actually see bees doing the dance. And when they're doing the dance all different directions, they haven't decided yet. But after a little while, they start dancing more emphatically, and some of them start, it's the debate that's going on, and some of them will start being convinced and they'll repeat one of the dance, and you'll see which direction that they're gonna go from that. They also have bumpers. And those bumpers are people that break up the debate. They'll go over and there's one bee that's just insisting you're gonna go this way, when the rest of them are saying we're gonna go that way, and they'll go over and break up his dance. So it's a division of a social unit. We think we understand a lot of things. We've been studying bees for thousands of years. We've come to understand their anatomy, but I'm not gonna get into anatomy tonight. We understand their communication to some extent. We make some assumptions that colonies are families, that queens fly away for their mating in order to have more genetic pool available. Swarms are are a way of preserving the family's genetics. Foraging we understand pretty well. Millions of years, bees and flowers have worked together. Flowers are not pretty for us. They are pretty to us, but they're not pretty for us. They're pretty for pollinators. They attract pollinators. And with their ultraviolet vision, the bees see flowers differently than we do. They actually have indicators where the flower needs to be touched. in order to produce seeds. So there's a bee on a flower. I think that's a crocus actually. But you can see the pollen all over the bee's body. It might be collecting pollen. At this point it's collecting nectar. But it gets pollen all over its body. And honeybees tend to stay with one flower over and over. They're sort of monogamous. And so it will go to another crocus and some of that pollen will fall off, and that's how they get pollination. We understand hoarding. Some of us are hoarders. And bees are good hoarders, and part of the trick for beekeepers is to convince the bees that they need more honey than they need. And that way we get surplus honey. So that's something that we have, that's probably one of the hardest things that beekeepers have, is deciding what's surplus and how much do the bees need. But we always need to leave enough for the bees. We never want to leave the bees hungry. From our perspective, it's a natural instinctive behavior. It promotes and protects the species. I gotta go faster. People are afraid of swarms. They don't need to be. Bees are very gentle during swarming. I'm gonna go fast because I was running out of time. Colony can be too crowded. This is sort of an important thing. The queen pheromone is too dispersed. Swarming time, in order for them to swarm, everything needs to be right. Or the expression I use, everything's green in the garden. It's springtime normally when swarms happen, the flowers are good, the weather's nice, and there's a balance in the population of the colony. And when I talk about balance, I'm talking about it takes 21 days for a bee to develop. It takes 42 days for a bee's life. So there you already know that you have more bees than you have brood by about 2. And then the population is broken in very evenly into different segments. And if it's not in balance, they won't swarm. So I actually use balance of the colony to control swarming. We don't want our bees to swarm. When our bees swarm, you can say goodbye to your honey for the year. Now swarms are nice to catch, but they're not nice if you want honey. You'll get honey from them next year. The queen's put on a diet, lots of food, brood in place, replacement queen cells are already maturing. There's some queen cells there. The democracy I talked about. They have all the resources they need. They fill their honey stomach and they're able to make a lot of wax when they find a new house. So they're all ready to go. So there's a swarm that's easy to catch. They're not all that easy. That's not very high. You can watch the dance on something like that. You can just shake that branch into a hive and you've caught a swarm. But sometimes they're too high. I've caught swarms higher than the ceiling, and I won't do it now. Division of labor we talked about. Defensiveness we can relate to. It's deadly for the bees because that pulls the stinger out and part of their intestines with it. Clustering is what they do in the winter to keep warm. They start clustering about 54 degrees Fahrenheit. Occasional flights can take place at temperatures as low as 45 degrees, but it's unusual. Today the bees were flying. Colonies don't heat the room, they heat the cluster. Basically, the bees that are on the inside of the cluster are eating food and creating heat, and the bees on the outside are insulating the cluster. And then they slowly rotate and change places. And that's how they keep warm during the winter. If we didn't have heat, we would be in a smaller space. Okay, this is the last one. The colony changes its population size throughout the year. So in the fall, the population starts dwindling. This time of year, it's as low as it's going to go because they're starting to make brood. That brood's going to start hatching next month, and then the population is going to start developing. When we have cold spells, like in March or something like that, that's dangerous for the bees. You have to make sure that they have enough food. I won't explain the nectar thing, but the size of the colony has to do with weather and available resources. So basically, I thank everybody for listening, but mostly I thank beekeepers and researchers around the world because they're learning all the time and they're teaching me. And I'm supposed to hurry up. And so
Keep telling
I was supposed to hurry up 10 minutes ago. So thank you.